So it became evident in the beginning of the project that us researchers expecting the highest quality images all the time, and it's a no-brainer to use them, but we came to the understanding that we should do a quick case study to find the effects of what different scanning parameters affect, how the different scanning parameters affect OCR quality. Okay. Right. Okay, so I'm just going to cover very quickly the background of this, then we'll move into the image selection, what kind of images we use to perform the tests. I'll very quickly outline the methods and procedures we use to carry out the tests, and then I will focus on the experiments. The first experiment is an examination of whether color, grayscale, or bitonal actually is better. Okay, that's in inverted commas. What is better depends very much on the application. But it's a study that actually creates more questions in some way than answers, but it was very nice to see the different things to discuss. Second experiment talks about the effects of resolution, right? So do you scan in high resolution or low resolution? Does it really affect the OCR quality? Okay, that's something that we've not had so much. And then there's the third experiment. I will explain a bit more in the background slide in the next slide, about the comparison, brief comparison with the National Library of New Zealand images that Tracy and Gordon, as I mentioned, had a paper before, as Richard mentioned in the first talk. Right? So as it was mentioned this morning, cannot escape that cost of storage is a real issue for content holders. So instead of, if you have a lot of bitonal images, so it's 1 bit per pixel, right? Or grayscale is 8 bits per pixel, and color would be 24 or more. Right? So to store this increased amount of data is quite costly to store it and maintain it, right? Scanning, I think, is probably a similar cost. Grayscale and Bitonal, I'm not sure, per class probably mentioned. So it was very interesting to read the study by Tracy Powell and Gordon Painter of the National Library of New Zealand. Richard mentioned that this morning as well. So I'm mentioning again, it was in the D-Lib journal in 2009, which opened a number of very interesting questions. So briefly, for the images, they considered whether it was really worth going to grayscale and storing these images and OCRing from grayscale, or would bitonal be sufficient? Okay, just in a nutshell. So we'll discuss this a bit more in the actual experiment. So the aim of this case study was first of all to examine the effects of color, as well as grayscale and bitonal in OCR quality. Of course, when you say bitonal, which bitonal is it? Which algorithm did you use? Is it the bitonal that the scanner produces? Because the scanner was scanning grayscale, right? And we just output bitonal. Is that the best algorithm, or can we find a better algorithm? So you're scanning grayscale, but you're running through an alternative, possibly better algorithm to produce the bitonal. So we're going to examine the effects of producing bitonal images in different ways. Then we want to examine the effects of different resolutions. So how would an OCR benefit from a high resolution, perhaps? And finally, we want to study the results by image, or image type, or document type, rather than the averages, right? So you will see the difference in my slides. Okay, so we selected images in a qualitative way, which means we didn't take thousands of images and hope to have a statistical distribution. Rather, we used our expertise to select images across a variety of newspapers. It was from the British Library collection that they had completed some tests, and they digitized many different types of newspapers of different qualities, of different eras, with graphics, with text, with different levels of usage and quality. So that was very good. They digitized from paper, and it was scanned in color, as well as grayscale and bitonal. So we were able to compare that, and we generated the images in between. The quality of the overall page was taken into account. So a newspaper where the overall page was bad or not as good, we selected some of those, and some that are average in terms of the sample, and some that were pretty good. Now our human eyes lie to us, of course, right? And it's quickly evident that what looks very good may not be the best for OCR anyway, right? As we know. Now, we selected from, it's very common in newspaper pages that the quality varies across the page as well. So in some pages, the inking may be very strong, dense in some part, and in some parts will be very, very faint, right? So we selected different parts. So again, an average is not perhaps the best way to calculate quality. So an adaptive algorithm, locally adaptive that scores better, could be better. So we selected images from different qualities across the page and across different pages. So we try to be as representative as possible with a fewer number of images and a huge statistical sample. We selected only text regions because we want to apply OCR and not to any other graphics, and no separators or images or so on in the samples. And we used only parts of newspapers, as I mentioned, no layout issues, right? We didn't want to test layout analysis. We didn't want to evaluate whether an OCR, the layout analysis part of an OCR segments the columns right. So we just selected pieces of text, basically, parts of columns. And of course, we were careful not to include text with any additional artifacts, any problems such as warping due to humidity that Hilde showed before, or other things that affect OCR quality in a different way. We wanted to evaluate just OCR on a relatively free from other artifacts images. Okay, right. Oops. So what we did, we used some of our tools developed in Impact. We marked appropriate regions using the Alithia ground truthing tool that we had developed in Impact, and we saved it as extracted from the main image as separate page files. This is a format developed by Impact, XML format that's very detailed to store all these outlines and text and so on. The text was actually keyed to be 100% correct, so that's our ground truth, and stored again in that format, which enables us to evaluate using again the impact evaluation tools, the OCR evaluation tool in this case. And we run the AB Fine Reader 9 engine, right, from the SDK. Okay. And for the algorithms which we run to binarize, say, or to reduce the color from color to grayscale, or from color to bitonal, we use what we deemed as the standard methods. That means some of the best research methods we could find, and some of the standard methods you find in products, right, including the binary racialization of ABI and some other from well-known packages of image analysis, right? Okay, so that's the main study. So you will see at first we have the color from the scanner. I apologize, I don't know why this appears like this. Sorry. The bad layout. So this is the image. They call it the result of OCR 89.49. That's across all the samples, right? That's an average. So this is the whole result, and this is the variation between the different images. Okay. And we see immediately the big difference between if we have the images in color and we send them to OCR, and if we have them in bitonal from the scanner. Okay, so it's about 10% difference, and a very large variation in quality between images of OCR, right? It varies quite a lot. Some images will be better than this, and some will be a lot worse. Okay, whereas this is far more consistent. Now, this is an aberration. This is quite a big problem, and we specifically included it because there are some collections that claim to have grayscale images, but actually they are dithered. So dithering is a technique that uses just black and white pixels to create the effect from a distance that is grayscale, right? And that is the worst for OCR, as you can see, right? As a reinforcement method, I'll leave that there for people to be appalled, right? Okay, so from the color, we used another package to create 8-bit grayscale, right? So that's 256 shades of gray. And you get similar results, actually, yeah, from color and grayscale. That's something to think about later on about what OCR can really capitalize on and what it can't, right? Then we thought maybe to save space, instead of using 256 grayscales with 8 bits, just reduce that to half, and maybe if the newspaper was printed with black ink on white paper, right, we surely don't need 256 shades, right? So maybe reduce it and have an experiment. Does it affect? So with 4-bit grayscale, quality drops a bit, and the variation in quality is increasing, right? So maybe it's not the best option. Now we generated Bitonal with different methods as well. So with ABI, which is actually the method which recognizes the images, you can see pretty similar as the color. Otsu is a very common, very crude in some ways, but fast and effective for many images, but very, very crude, very crude binarization method, right? It's no brains at all, right? And you see how much better than the Bitonal of the scanner it is, right? And then it's another research method developed by another team in Impact as well, in NCSR in Greece. And it's pretty close as well to 90% as well. Okay, so I suppose the message to take from here is that Bitonal from the scanner, on the whole, is worse, and there's bigger variation in quality between images. And if one has to go Bitonal, it is sometimes better to use a different method, right? Now, as I said, these are averages, right? And if you have many different types of images, and you see some newspaper images look completely different than others, right? The way they were produced, the paper used, and the ink used, and so on. So we should group all those, perhaps, and identify which parameters are better for different types of documents, right? So let's say just a quick graph there. So you're not supposed to read that, the small text. It's just to show the variation as per image, how big gaps could be in performance if you binarize with different methods, right? So you can see wide gaps in some cases, right? So finding the best binarization method if you have to go binary, Bitonal, makes a big difference. So that is the result. In blue, you see these are all the images from the British Library collection we actually used, and the blue bars are the OCR result using the best binarization method we could find for that image. Okay, and in some cases, I mean, you see large differences there. Okay, some huge differences in some cases in there, and in almost all cases, apart from some spurious ones, we're not sure, the Bitonal of the scanner is better. But on the whole, the best Bitonal is not the one that is fixed in the scanner software. Okay, that's important to know. If you have to go Bitonal, you might as well choose the best algorithm for that particular type of image. Okay, and to show, for example, what would be helpful is to actually look at each one of these images. I'm not going to do it now, and see which one actually benefits from which method, because each of these blue ones are mostly from a different method, right? Oops. Okay, so this is one example where there was a huge variation. I'll show you. That's this one. Sorry, I think there's 9. This one, yeah. So the Bitonal from the scanner achieved under 10% accuracy, and just OCRing with the best, the Bitonal using the best algorithm is just over 70%. Yeah, still not very good, but hugely better than the scanner. And that's that image. And I looked at the Bitonal produced by the scanner, and it is unreadable, right? It missed all the faint text. And on the face of it, I included it because it doesn't look that bad, right? Okay. Right. So the second experiment is to do with the effects of resolution, right? So the first bar is when we scanned. Again, these are average, and I'm only talking about word accuracy, by the way, right? Character accuracy would be higher than all these cases, slightly higher, but as I gathered from most applications, word accuracy is the most meaningful if you want to retrieve words and so on. Yeah? So the first is the result using 300 dpi scans, and then you have 400 dpi and 500 dpi. And it's quite interesting that it appears that actually if you use the 500 dpi, you get slightly less accuracy and much higher variation. It does get a little bit better with 400 dpi. Okay, that's the case. Increases a little bit and then drops. And that's quite interesting actually, because you have more data and you're supposed to do much better, right? But there are many effects that perhaps the image is larger, you have more pixels than you need, perhaps. And the other thing which I have in my conclusions also in a minute is that perhaps OCR manufacturers only assume that people are scanning about 300 dpi and optimize the methods according to that. So there could be a lot of room for improvement if you have the more data. Okay. Now, moving on. The third experiment examined a little bit the images. So Tracy was kind to give us all the images they used in their experiment in the paper. Just to put things into context, all the digitization takes place from microfilmed images. And on average, the quality is quite good. So the results, as you see, are between 80 and 90%. And applying the same principle for different snippets of images, we see that in some cases the best binarization algorithm produces better results using a better bitonal than the actual scanner. Okay, so the blue again is the best algorithm. The yellow, the orange is actually what comes out from the scanner. Okay, and in some cases, the scanner is better. So what do we learn from this is that we really need to look at the individual images and try the different algorithms. It's possible through workflows to identify the best algorithm for a batch of documents and really kind of do that. If apply that algorithm. If you have to go to Bitonal, that is. Okay. Just to explain, just to give you an idea that just by looking at things is not enough to determine which is going to give you better OCR. Rather, we have to apply systematic analysis of the results using ground truth. That's why we have all these tools in Impact. So this one, for example, which looks worse, the other Bitonal algorithm performed better than the one from the scanner, right? Whereas the scanner Bitonal, this one with a lot of bleed through and stuff, was better than one of the best algorithms in binarization. So we really need to apply in a methodical way and find out which one is best. Okay. Right. Concluding. There are certain things. I think, as I said, there are many questions to think about. Right. Just a few summaries there. So on the whole, if we look at averages over collections, it doesn't give us a lot of meaningful results. Right. So if we have a method to digitize, a way to digitize newspapers, that doesn't really mean anything, right? It's better to focus on grouping parts of collections that are similar and applying a workflow to those parts, right? So we should make different decisions for different document types. Okay, most studies look at just averages. Secondly, the better quality images always leave room for future improvement, right? Especially when we see results, even in the best cases where Bitonal and grayscale in the New Zealand images are about 85-86% accuracy. There's still a lot of room for improvement for OCR from 85 in theory, right? And in practice as well. And say in 10 years or in 5 years, people can just, if you have a good quality image, you can just re-OCR without rescanning. So it is an investment, a good quality image. The third question is whether OCR systems are taking advantage of extra quality or not, right? My feeling is they optimize for maths projects so far, and mostly not in historical documents, but even though they assume there are certain parameters that are tuned for 300 dpi, for example, and grayscale. So, but definitely higher quality is an investment, as I said. At least grayscale, not Bitonal. Okay, maybe color is not so important, but you can get things out of color that you cannot from grayscale. But perhaps the high resolution is not so necessary. Okay, so savings can be made that way, right? Not 500 dpi, for example, is not so necessary. And I'm so sorry about this. It wasn't in my original slides. The interesting thing is, I'll rephrase from here. Lossy compression is something people should look about. It's a totally different discussion and heat contest kind of issue. But just think about this, right? It's much better to have a high quality image with a few imperceptible differences than have a bad quality image with perfectly preserved. Okay, so I'll stop on this note. Okay. Yes.